Welcome to the Bodhi Academy. My name is Amisha Kulaso, and in today's video we will start with a new chapter of class 8, chapter 1, rational numbers. So now, as we have studied previously in class 7 about rational numbers. So rational numbers are denoted in the form of P by Q, where Q is not equal to 0. So rational numbers, they are any fractions that are denoted in the form of P by Q and where Q should not be 0. P is the numerator and Q is the denominator, which cannot be equal to 0. So these are known as the rational numbers. Some example would be say 2 upon 5, then we can have 3 upon 2, 1 upon 5. These all are rational numbers. Even 0 upon 2, these are rational numbers. So now let's move ahead and look at some of the properties of rational numbers. So to begin with, let's look at the closure property. So we will look at this closure property with respect to whole numbers, and we'll see if this closure property is followed by these different operations, that is addition, subtraction, multiplication and division. So now first we have addition. So say I have 0 plus 5, that will be equal to 5. Or say I have 2 plus 3, that will also be equal to 5. Or say 8 plus 2, that is equal to 10. Now these all numbers are, that is 0, 5 and 10, these all are whole numbers. So therefore, on addition of any two whole numbers, let us say you have A plus B and your answer is C. Here we can say that on adding A plus B we get C, and C is also a whole number. This set of number is also a whole number. So therefore A plus B equals to C. Therefore addition of any two whole numbers gives us another whole number. So we can say therefore A, B and C are whole numbers. So therefore what can we say, that the whole numbers are closed under addition. Okay. So now let's look at the next example. So we have next is the subtraction. Now say I have 5 minus 5, then say I have 2 minus 8, and say maybe 2 minus 3. Okay, so 2 minus 3, and maybe say, now let's another example, 5 minus 8. Now in this case what we can see, 5 minus 5 is 0, 2 minus 8 will be minus 6, 2 minus 3 will be minus 1, and 5 minus 8 will be minus 3. Now in this case, see the first case, in this case we are getting a whole number, but rest of the cases minus 1, minus 6 and minus 3 are not whole numbers. So these aren't whole numbers. So therefore what we can say, that when we have A minus B equals to C, A and B are whole numbers. Okay, but C is not a whole number. So therefore what we can say is that subtraction whole numbers are not closed under subtraction, or we can say that the closure property is not obeyed when we are doing subtraction. Now let's go ahead and look at multiplication. So now say I have 2 into 3. Okay, I have 2 into 3. In this case what will get? 6. Okay. Then say I have 0 into 3 and this is also 0. So therefore these two are whole numbers. So therefore A into B equals to C, where A, B and C are whole numbers. Correct? So therefore whole numbers are closed under the multiplication property. Last we have the division part. Now say I take an example of 5 divided by 8. In this case what we will get? 5 upon 8. Then we have say 2 divided by 3. In this case also what we will get? 2 upon 3. So these are not whole numbers, even though the products, the numbers that we are multiplying, these two are whole numbers, but the product isn't a whole number. Therefore we can say that division whole numbers are not closed under division property. So from this what we can conclude, that the closure property, it is obeyed only by addition and multiplication, whereas it is not obeyed by subtraction and division. So now let's move ahead and look at the integers if they follow the closure property. Now say, okay, you have to do addition. So say I have -3 and +5. So in this case the answer would be 2. Next say I have 8 -8 plus -3. In this case what I'll get? This will be minus. So then I have to add it. So minus will become plus. 8 plus 3, 8, 9, 10, 11. So minus 11 because sign of the greater number. Now you see here these two. These are our integers. These all numbers that we are adding are the integers, as well as the answers that we are getting are integers. Integers are what? They are a combination of positive as well as negative numbers. So these answers are also integers. So therefore we can say that integers are closed under addition. Okay, so that was the closure property of integer. So here we can write what? Say I have A plus B equals to C. Therefore our A, B and C all are integers. Now let's look at subtraction. Now same examples will take -3 and -3 and minus 5. So what I'll get? 5, 6, 7, 8. So answer will be minus 8 here. Then I have say minus 8 minus 3. This will give me, this will come plus. So then minus 8 plus 3, that will be 5. So minus 5. In this case also, or maybe let's take another example like 9 minus 2. So answer will be 7. So in this case also, all minus 8, minus 5 and 7 are integers. Okay. So therefore, integers are closed under subtraction as well. So here we can write a minus b equals to c, where a, b and c are integers. Now let's look at multiplication part of it. So now say I have 3 into minus 5. So this will give me minus 15. Say I have minus 9 into minus 2. This will become 9 2s are 18. Minus into minus becomes plus. So in this case also we are getting integers, correct? So we can say that the same closure property is being followed by integers as well. So a into b equals to c, where a, b and c are integers. Okay, and integers are closed under multiplication, correct? Last we have division. Now let's look at the division part of it. Okay, so example, say I have minus 3 upon 5. In this case it will be minus 3 upon 5, or say write it down like this, minus 3 divided by 5. Now this is not a integer, correct? Integers are whole numbers we say. Then what we can say here is that this will be, say another example we can take, minus 2 divided by minus 3. In that case also, if we take minus 2 upon minus 3, our signs will get cancelled, and these two are not integers. So therefore what we can say about division is that a divided by b giving c, where a and b are integers and c are not integers. Okay, and here we can write integers are not closed under division. Now last, let's look at the rational numbers property. So here we are going to use all the rational numbers. So now let's take an example for the first one. Two rational numbers, say we are adding, say I have 2 upon 3 plus 5 upon 3. In this case the answer will be what? 7 upon 3. So this is also a rational number. Okay, so then say I have 0 upon 2 plus 8 upon 2. In this case what I'll get? This will be 8 upon 2. So these are also rational numbers. Rational numbers, what we said, that it is p by q format, where q shouldn't be 0. Here we have taken 0 in the numerator, correct? So therefore it becomes a rational number. So what we can say, that rational numbers are closed under addition. Okay, so here when we do a plus b equals to c, a, b and c are rational numbers. Rn, let's consider that as rational numbers. Next, let's look at subtraction. Example, okay, so minus 5 upon 7 minus 2 upon 3. Here what we'll have to do, we'll make the denominator same. So for that, this will be 21. So 7 3s are into 3, so come 7 into 7. So therefore we'll get 15 upon 21 minus 15 upon 21 and 14 upon 21. So that will give us, this is now minus into minus, so minus 15 minus 14 upon 21. So that would be a total of 9 and 2. So sign of greater number minus upon 21. So this so we get minus 29 upon 21. So that is also a rational number. So what we can say, that any difference between any two rational numbers also ends up giving us a rational number. So therefore a minus b, okay, this will be like, we'll say p by q format. Correction here, because we are talking about rational numbers, it will be p by q plus p by q gives us a p by q. Here also p by q minus p by q gives us a p by q. Next, so here we can write rational numbers are closed under subtraction. Okay, then let's go down and let's look at the product of any two rational numbers. Say I have minus 5 upon 3 into 2 upon 4 and I have minus 8 upon 1 into 0 upon 3. So in this case what I will get answer, this will be 10 minus 10 upon 12, and here I'll get minus 8 into 0 is 0, so this minus is not considered here, so 0 upon 3. Now these two are also rational numbers, so we can say that rational numbers are closed under multiplication. Correct? And we can say that p by q into p by q gives us a p by q. Last, let's look at the division part. Say I have minus 3 by 8 divided by, it is given minus 2 by 9. Now this will give me, even on further dividing, I will get minus 25 upon 9, which is not a rational number. See, sorry, 25 upon 6. This will be 6. Minus 25 upon 6 we are getting, correct? That is a rational number. But then let's see, you have, again we have 2 by 5 upon 7 by 3. That will also be a rational number. Say 2 by 7, 3 by 5, 6 upon 35. So that is also a rational number. Now let's see if we find out that for any rational number a divided by 0 is not defined. So say I have 3 divided by 0. In this case, this becomes not defined, and this does not fall under the rational numbers category, where we say p by q and q should not be equal to 0. So therefore we say that rational numbers are not closed under division. So when we have say 3 by 0, we'll get 3 by 0. This is not a rational number. So therefore we can say rational numbers are not closed under division. Okay, so now in this, for rational numbers, we know that addition, subtraction and multiplication, they are all closed under closure property, whereas division is not. Okay, so that was it for today's video. Please don't forget to like, share and subscribe to the Bodhi Academy.